So today we're going to be talking about day 7, which is infinite limits and limits at infinity. So the difference there, when we're talking about infinite limits, this is when we're talking about our answer is going to be either positive or negative infinity. So our answer is going to either be positive or negative infinity. So when your limit looks like the limit as x approaches some number a of f of x, and our answer is positive or negative infinity. Okay, so we want to look at a couple of limits here. They're going to go with this graph. So this says the limit as x approaches 2 from the left of f of x. So we're using this graph. We want to come in 2 from the left. So here's 2. As we come in 2 from the left here, that keeps getting smaller and smaller, so that is giving us negative infinity. And then the next one says the limit as x approaches negative 1 from the left, but now we're using g of x. So here's negative 1. As we come in from the left side, it also keeps going down forever, so that's also approaching negative infinity. So these two are examples of infinite limits because their answers are negative infinities. So when you have answers or infinite limits, so answers that are negative or positive infinity, that tells you that you have a vertical asymptote at your x equals a. Move this up here. So whenever we have infinite limits, this is when we have vertical asymptotes. Okay, so whenever your answers are positive or negative infinity, that's when we have a vertical asymptote at whatever the a value is there. Alright, when we're looking at limits at infinity, this is when you're talking about x is approaching either positive or negative infinity. Okay, so this is when we're talking about looking at the end behavior. So if I ask you, like, what's going on the left side or the right side? So this limit would look like the limit as x approaches either positive or negative infinity of f of x equals, and it'll give you some answer. So two examples of this. First one we want to find is the limit as x approaches infinity of f of x. So we're using f of x. Because this says as x approaches infinity, we're looking at the right end behavior. So here's the right end behavior. As you can see, this graph's getting closer and closer to that horizontal asymptote, which is at 2. And then this says the limit as x approaches infinity. And now we're looking for g of x. So on g of x as x approaches infinity, this is actually going to keep going up forever and ever. So this is going to approach infinity. So when we're talking about limits at infinity, this is going to go with our horizontal asymptote. So it's going to be end behavior. So this is going to talk about horizontal asymptotes. And then, like you can see on G here, if it goes to infinity, it could be having a slant asymptote there. So the slant asymptotes would be when you get your answers of positive or negative infinity. Horizontal asymptotes would be when you get an answer that's an actual real number. Okay, so there's the difference. So sometimes we're talking about infinite limits, which is when our answers are infinities. Then we have vertical asymptotes at our x equals a. And then if the limit is asking about positive or negative infinities, or asking about the end behavior, our answers give us either horizontal asymptotes or they can give us slant asymptotes. Alright, so next. So we have this justification of the existence of a vertical asymptote using limits. So what this says is x equals a is a vertical asymptote of f of x if and only if the limit as x approaches a from the left of f of x equals either positive or negative infinity, or, so that means they don't both have to be true, only one has to be true, the limit as x approaches a from the right of f of x equals positive or negative infinity. So this is not anything new. We've already looked at this a couple of times. We looked at it in tables, we looked at it in graphs, but it's just saying if you can prove that either the left side of the limit gives you positive or negative infinity, or the right side of the limit gives you positive and negative infinity, that means that x equals a, which is your here value, has to be a vertical asymptote. Okay, because the only way for it to be approaching either positive or negative infinity is if that a would have been a vertical asymptote. Alright, so for example 1, we're going to find the vertical asymptotes first using ways that you've learned in previous classes like pre-cal, and then we're going to justify our answer using the limit. So, before we can find the vertical asymptotes, we do need a factor. So if we factor this original part here, I'll come over here and factor. Okay, so go ahead and just factor 2 times 3 gives us 6. Two things that multiply to 6 and add to 7, 6 and 1. So make your 4 terms. And then our GCS. Okay, so when you factor that numerator, it should give you 2x plus 1 times x plus 3. And then when you factor the denominator, that'll give you x plus 3 and x minus 1. So our x plus 3 are going to cancel. Remember, to get vertical asymptotes is whatever's left over in the denominator. Alright, so this is x minus 1 equals 0, so x equals 1. So we should have a vertical asymptote at x equals 1. So now we want to justify our answer using limits. So what it says is in order to prove it's a limit, you have to do either the left side or the right side of the limits at your x equals a. So we're going to do the limit as x approaches 1, we'll do from the left of our h of x. Okay, so once if you tried to plug in 1 here, it would be 1 plus 2 minus 3, which would give you 0 in the denominator. So you would have factored. So think about if we have the limit as x approaches 1 from the left of what's left over. So of 2x plus 1 over x minus 1. Well, you can't plug in again. So that means x equals 1 is a vertical asymptote. So remember, to figure out if it's positive or negative infinity, you would plug in either a bigger or smaller number depending on what the problem's asking for. So because this says 1 to the left is the one that we picked, I'm going to plug in x equals 0.9. So I'm going to plug that in. So we'll have 2 times 0.9 plus 1 over 0.9 minus 1. So in the numerator, we'll get a positive answer. In the denominator, we'll get a negative answer. So that'll give us a negative answer. Okay, so this tells us that the limit as x approaches 1 from the left is equal to negative infinity. Well, what the theorem up there says, or the existence says, therefore, now we know that means x equals 1 is a vertical asymptote. So because our limit as x approaches 1 from the left was negative infinity, we can know that that x equals 1 is a vertical asymptote. So we just really found this 2 different ways. Okay, we knew how to do this algebraically, but we just proved using a limit that it does have to be a vertical asymptote. And you could have also picked the right side. You pick the right side, as long as you get a positive or negative infinity, then that tells you that it's a vertical asymptote. But just remember that the existence theorem says or here, so that's why you only have to do one of the sides.